All right, so 3.4 measures of position and outliers. Write that better. All right, so the first thing that this section talks about are your z-scores. They're going to represent the distance a data value is from the mean in terms of standard deviations. So the distance the data value is from the mean in terms of standard deviations. All right, so the way we'll calculate our z-scores, the general formula is right here, your data value minus the mean divided by the standard deviation. All right, now if you're using your population versus your sample, you had different symbols. Remember we talked about that last class. Notation would be different, but the format or the setup will be the same. Your data value, which is x, minus the mean divided by your standard deviation. So the green is your population symbols, purple just your sample symbols. But once again, it still means the same thing, data value minus the mean divided by the standard deviation. All right, few characteristics of your standard of your z-score. It is unitless, and it has the mean of 0, standard deviation of 1. In other words, when we go to the chart, we're not going to do it in this section, but we will eventually. When we go to the chart, you will see that 0 will be in the middle where our mean would be, and then go out, by ones using the standard deviation. Similar to how the empirical rules, you go out one standard deviation each time. All right. Let me know if I'm scrolling up and you still copying. All right. So, first example, determine whether the Angels or Rockies had a relatively better run producing season. The Angels scored 773 runs and play in the American League, where the mean was 677.4 and the standard deviation was 51.7. The Rockies scored 755 runs and play in the National League, where the mean was 640 and standard deviation was 55.9. So I'll give you a chance to write that down. All right. So once again, we want to determine whether the Angels or the Rockies had a relatively better run producing season. Angels play in the American League, um, Rockies play in the National League. So if you ever watch baseball, you know that that matters because there are slightly different rules depending on what league you're in. So looking at our given information, in the red we have our Angels. They have 773 runs, so that will be our X with a mean of 677.4, standard deviation of 51.7. Rockies has 755 runs, 640 is the average in the National League, and 55.9 is the standard deviation. All right, so we take each one of them, find the z-score. So for the Angels, 773 minus 677.4 divided by 51.7, that's 1.85. And did I write that? Okay, yeah, right here. And those, we're always going to round our z-scores to 2 decimal places. So that's going to matter later on as we progress forward throughout the book. So we'll always round our z-scores to 2 decimal places. So then with the Rockies, we do 755 minus 640 divided by 55.9. That'll be 2.06. All right, any questions so far? All right, so what that means for us, the Angels scored 1.85 standard deviations above the mean. The Rockies scored 2.06 standard deviations above the mean. Underlined above right here because our values are positive. If it was negative, then you would have said they scored below the mean. So it is possible for your z-score to be negative. In this case, both of them were positive, so both of them scored, 1 point whatever the value was above the mean. But if it was negative, then it would have been below the mean. So that just means the Rockies, who scored 2.06 standard deviations above the mean, had a better run producing year. All right, questions, questions, questions. All right, put it right there. Percentiles. The kth percentile of a set of data is a value such that k% of the observations are less than or equal to the value. Kth percentile is denoted by P sub k. All right. So Jennifer just received the results of her SAT exam. Her SAT math score of 600 is in the 74th percentile. What does this mean? So give you a chance to write it. All right, so what does this mean? 74% of the people who took the exam scored 600 or less. Remember that your percentile, your kid's percentile represent that number or less. So 74% of the people who took the exam scored 600 or less. And 26% scored better. So we got a 26% by doing 100 minus 74. All right, any questions on that? All right, next thing is the quartiles. So quartiles divide the data set into fourths. So if this line represents your data set, your minimum value, maximum value will be your bookends. Then Q1, Q2, Q3, or in other words, quartile 1, quartile 2, and quartile 3 would be the values that will separate your data into fourths. All right. So finding our quartiles, we're going to list our data values from least to greatest. That's always your first move, because what we'll find out is that really our quartiles are just medians. And remember, first move on finding your median is to list your data value from least to greatest. So we list our data values from least to greatest. Find Q2 first. That's going to be the median of the whole data set. So the middle value of the whole data set. Then we'll find Q1. That's the middle value. Middle value of the first half of data. Then Q3 is going to be a middle value or the median of the second half of data. All right. Everybody good, everybody straight.
Why do you do it in that specific order?
Because what's going to happen is, let's say if this line represents our data set, and remember, we're going to split our data into fourths. So it's easier if I find Q2 first, because then that splits my data into 50%. Then split this in half and split this in half. So that's the easiest way to do it. But you see when we're about to go through the process in a second. So.
Okay.
All right. So I'm just going to go through, I think is, yep. So we're going to look at interquarter range. So I'm just going to give you all of the processes, then we're going to walk through them, through all of them. So your interquarter range, IQR, that's the range of the middle 50% of your data. And you will find that by taking Q3 and subtracting Q1 from it. All right. Checking for outliers. So remember, I think we mentioned outliers before. If not, you should have saw them in your definitions. So outliers are very extreme values in reference to your data set. They can be very, very large or very, very small. So the way we're going to check for our outliers is that we are going to be able to establish what they call an upper fence and a lower fence. In other words, these are going to be numbers that will say, as a matter of fact, it's right here in the green. So everybody done with the IQR? Okay. So if a data value is greater than the upper fence, then it is an outlier. I'll write that word fence better. All right. And then if a data value is less than the lower fence, it's an outlier. So we're going to have these numbers that's going to be created by doing Q3 plus 1.5 times the IQR, that will be your upper fence. And then Q1 minus 1.5 times the IQR will be your lower fence. Once again, if a number is greater than the upper fence, it's considered an outlier. And if it's less than the lower fence, it's considered an outlier. Or if it's less than the lower fence, it's considered an outlier. All right. So that prevents us from having to sit here and guess if something is an outlier or not. All right. So let's try this out. Are you done with the green? All right, let me erase some of this stuff so we can walk through it. What did I just erase? Yeah. All right.
Could you show the lower fence thing one more time?
Talking about that part?
Yeah.
So let me know when you're ready.
Yeah, I'm all good. Appreciate it.
Not a problem. What about the green? Anybody still holding on to the green? All right, so here we have our data set, and we're going to perform what we just all those steps that I just finished talking about. We're going to find our quartiles, going to find IQR, establish our upper and lower fence, and see if we have any outliers. So we have 180, 189, 370, 618, 735, 802, 1185, 1414, 1657. Now, I wrote these in order. I went ahead and wrote them in order versus me writing them out of order, then writing them again in order. I just went ahead and wrote them in order. We have 18 data values right here. So I split them up, 9 here, 9 down here. So in the bottom half, 1953, 2332, 2336, 3461, 4668, then we have 6751, 9908, 10,034, then 21,147. So I'll give you a chance to write those down. All right. So first step after listing your data values from least to greatest. So notice I put a 1 right here for that list. Then second step will be finding Q2. Messing up all over the place. Finding Q2. So we have 18 data values. So remember, whenever you're trying to find a median, if you have an even number of data values, you have to take your 2 middle values. That's going to be 1657 and 1953. Add them together and divide by 2, and that will be your median. So now if it's an odd number of data values, you just take the middle. But if you have an even number of data values, you take your 2 middle values, add them together, divide by 2. All right. Next move or next step is to find Q1. So Q1, since we have 9 data values in the first half of data, 735 will be that middle value. We have odd number of data values. So we go ahead and pick out our middle number, which is 735. All right. There is an odd number of data values in our second half of data, of course, that's 9. So we just pick the middle value there, which is 4668. All right, any questions? Steps 1 through 4. All right. Step 5, IQR is Q3 minus Q1. So for this one, it's just 3933. We did 4668 minus 735. All right. So now we can determine our fences. Remember, we have an upper fence and lower fence. Let me know if I'm going too high. Well, upper fence is going to be Q3 plus 1.5 times the IQR. So 4668 plus 1.5 times 3933. That will ultimately give us 10,567.5. Then our lower fence, Q1 minus 1.5 times the IQR. So that's 735 minus 1.5 times 3933. And that will give us negative 5,164.5. Any questions with our fences? And I think I should put that at 7. So your last step, you want to, establish if there are any outliers or not. So are there any outliers? The answer is yes. And it is that 21,147. That number is greater than the upper fence. All right, questions, any questions? All right, that's it for 3-4. Is everybody good before we look at 3-5?
So in order for it to be an outlier, does it have to be more than the upper fence or less than the lower fence?
Exactly, yep. Yep. Other than that, no matter how big it is, no matter how small it is, if it still fits within the fences, they're not considered outliers.
All right.
All right, anybody else before we go to 3-5? Now 3-5 really piggybacks off of 3-4. Just add really one or two more things. So we're looking at 5-number summary and box plots. So your 5-number summary is your minimum, Q1, Q2, Q3, and your maximum. All right. So, we just found all 5 of those, just saw the process to finding all 5 of those. Box plots, graphical tool used to compare groups of data. It consists of a box with lines that extend to the minimum and maximum values that are not outliers. So what we're going to do in this section is what we call modifier box plots. If we found out that our value is an outlier, we will not extend the line or the box plot to it. You'll see what I mean in a second. And so these lines are called whiskers, these lines that extend from the box. And we will represent outliers with an asterisk. Try not to go too far up. So I'll go all the way down in a second. Just want to make sure everybody's with us.
So just to clarify, in a regular box plot, the whiskers will extend to the min and max, but we're going to represent them with whiskers.
No,
I mean, we were going to represent
no,
them with asterisks, sorry.
it's fine. No, it would extend to the min and max regardless. But if we find out that the maximum value, like that 21,147 that we had in our last example, that would be represented by an asterisk, and then it would extend to the next value up. You know, so regular box plot, these just go all the way to the max and the minimum regardless. But what we're going to do is, if we find out that one of our values, or more than one, if any of our values are outliers, we're going to represent them as asterisks, and then let the whiskers extend to the next value outside of the outlier. Like I say, next value down from the outlier. Yeah. All right. Questions before we, yep, just do an example. Those are only two things in this section. So they want you to give the 5-number summary and then do a box plot. All right, scrolling up. All right, so separate that. So directions, give the 5-number summary and sketch the box plot. So I wrote a little note here. Our data set is not always written from least to greatest. So make sure, that you do that before you do anything. Once again, to save on time and paper and all that, I'm just going ahead and write it in order, but your data set does not have to be given to you in order. All right, so well, I'll let you guys write that first before I show the whole data set. Don't want to leave anybody behind. All right. I'm going to erase some of this stuff so we can walk through it. And I kind of wrote this. All of these are the data values. You know, all of this one, all of it's data values. Just that I wrote it in such a way that our middle value Q2 is just sitting in the middle and split up our data. But of course, they would just give it to you all in, you know, 1995, comma, 23, comma, 23, comma, you know, all of those values. So I just wrote it, like I said, in such a way that we can clearly see what's our middle value. We have 21 values altogether. And 30.95 is our middle value. So that's going to be Q2. So I'll give you guys a chance to write that down. All right. Let me see something. I want to go back to. Oh, okay, I did it like that. Okay, so next move is to find Q1. So there are 21 data values altogether. We already established that our middle value is Q2. So that means we have 10 data values here. And then 10 data values down here. So that means we have an even number of data values in the first and second half of data. So we don't have a middle number. So we have to take the two middle values, add them together and divide by 2. So that's how we get 26.06 right here for Q1. All right, and then for Q3, take our two middle values, add them together, divide by 2. That'll give us 37.24. All right, questions? Any questions? All right, IQR, Q3 minus Q1. So 37.24 minus 26.06, 11.18. And once you find your IQR, you can establish your fences. So Q1 minus 1.5 times the IQR is your lower fence. That'll end up being 9.29. Q3 plus 1.5 times your IQR ends up being your upper fence, 51.04, 54.01. Wow. All right, and once again in red, just reminding us what those fences do for us. If a value is less than the lower fence or greater than the upper fence, it is an outlier. All right, questions, any questions? All right, last step, determine if anything we have, any data value we have is an outlier. So 54.63 is an outlier because it is greater than the upper fence. Any questions before we look at actually giving the answer? All right, so the 5-number summary, we have a minimum value, maximum value. Now that has nothing to do with what's an outlier or not, just that you have a minimum value and maximum value. Minimum value is 19.95. Max is at 54.63. Once again, 5-number summary has nothing to do with being an outlier or not. What is your minimum? What is your maximum? And then what is Q1, Q2, and Q3? So that's our 5-number summary. All right. And from there, our box plot would look like that. What's down here? Okay. So 1995 is our min, our minimum. Q1 26.06, Q2 in the middle with 30.95, Q3 37.24. Now, remember we have an outlier right here at 54.63. We're going to represent that as an asterisk. Then the next value up or next value down is that 49.17 in our data set, our data values. And that's what the whisker would extend out to. All right, questions, any questions? Everybody good, everybody straight. All right. So that is it for chapter 3. That's it for chapter 3. See what we have here. So it's going to be important for you guys, at this point, what we have that you guys have to do if you haven't done it. We have, let's see, homework. So we got in my math lab, we got homework from chapter 1, 2, and 3. You have a test. Just test 1. That's chapter 1 and 2. And got those definitions. If you haven't gotten them to me already, some people have. And so that's what we're looking at being responsible for at this moment. All right, so questions, concerns, anything, anybody? All right, so, all right, see a thumbs up, appreciate it. So next class, we will get into chapter 4. Chapter 4, it's only 3 sections. So next week, we'll be done with chapter 4. Trying not, and see, it's funny, I'm battling this whole balance thing of trying not to give you guys too much content, but at the same time, we're supposed to be in the class at like 9:45, 10 o'clock or something like that, right? I don't want to cheat you guys of the classroom experience. I know y'all were anticipating being in class all the way till 9:45. I know I'm letting some of you down. But so we only have 3, because see, we only have 3 sections in chapter 4. So if I really could do, if I have time from 6:30 all the way to 9:45, or what is it, 8:45, it might be 8:45, whatever it is, I could really cover all 3 of those sections in one class. So I'm battling, with this 8-week class type thing, because at the same time trying to be cognizant of just hitting y'all with a whole bunch of information and stuff like that all at one time. So I'm gonna figure it out though. I'm gonna figure it out. But just to let you know, what's coming up. Chapter 4 is on 3 sections, so that means your second test, test 2, is chapter 3 and 4. So that'll be what's on the horizon, along with chapter 4's homework. So, and see, you got all this work to do too. So it's not like we just cover stuff and then poof, there's a test, but you got homework that comes along with it. So I'm trying to I'm thinking about y'all as I do this stuff. So trying not to hit y'all with too much at one time. So before we close out today, is everybody all right? Everybody good? Everybody straight? Okay. All right. So I'll be posting these lectures between today and Friday. So look out for that email. Outside of that, if any questions come up between now and Monday, feel free to shoot me that email. I'll help you out as much as I can through email. We have to set up a Zoom session outside of that, and let me know. We can do that as well. Other than that, you guys have a great weekend. Be safe, and I will see you on Monday.
Thank you.
All right, no problem. Thank you.
You have a good one.
All right, you do the same. Take care.
Thank you.
Thank you.